Good morning and Jai Hind children. I welcome you all in today's live class of chemistry. Children, today I am going to revise the chapter structure of matter. Okay, that we have already finished. We have discussed all the topics and exercise, and again I am going to revise it. So please go through this revision very carefully. Now, the different topics that we have explained in this chapter, one by one, I will revise. So, the first topic is about the matter. Matter. Anything which is present in our surrounding, that is a kind of matter. And this matter is found in three states: solid state, liquid state, or gaseous state. And all these states are made up from the small particles. Okay, children? So the matter which is found in our surrounding, found in different states like solid, liquid, and gases, and they are made up of the small particles. And these small particles are termed as atoms. So the atoms are the smallest particle by which the matter of any kind is made up. Now the matter as anything present in our surrounding, so that thing it may be elements or the compounds. So there are two terms that comes here. That first one is elements. The substances who have the same kind of particles, substances which are made up of same kind of particles, that is atoms. And these atoms cannot be broken down again. So such substances are termed as elements. And the compounds are the substances which are made up from when two or more than two different elements are joined together in a definite ratio. So such a mixture of different elements of a definite ratio is termed as compounds. So the smallest particle by which an element is made up of is atom, and the smallest particle by which compound is made up of is molecule. Okay, children? So please understood these two terms, atoms and molecules. They both will consider as the small particles, but the atoms will consider as the smallest particle by which the elements are made up of, and the molecules will consider as the smallest particle by which compounds are made up of. Okay, children? So I hope that you understood about elements and compounds and atoms and molecules. Now come to the next, that is the properties of compounds. The compounds have the different properties, like the compounds are formed when the different elements are going to mix in a definite ratio, and they form by a chemical reaction, not by a physical method. By any chemical method they will form. So these are the properties of compounds. Okay. Now we already have explained in the chapter that as the elements are kept together, so either they form the compound or they form the mixture. So you must have to know the difference between compound and mixture also. Compound and mixtures. They both have the different terms as they are having the different properties. The compounds, when the elements two or more than two different kinds are get mixed together and react chemically, and they are present in a definite ratio, so that time it will termed as considered as compound. But when two or more than two elements are just kept physically and there is no any chemical reaction is going to occur and the ratios are also not fixed, so that time it will termed as the mixture. So they both are the group of the elements, but as the ratio of the elements and the chemical reaction which is going to occur, they are going to make them different compounds and mixture. Okay, children? Now, come to the next. The next one is that the symbols and the formula. The next important topic which is given in the chapter is symbol and formula. The symbol indicates that the representation are the abbreviation which are used to denote the elements. It is termed as symbol. So generally the alphabets are used and the first letter of the name of the elements are used as a symbol of the elements. But in some of the elements, the first letter of their name is not used. First two letters are used. For example, to indicate the carbon, the first letter, that is C, is used as a symbol. So we can say that the symbol of carbon is capital C. But the cobalt, its also first letter is C. But if we'll write C here, so it will make a confusion. So that is why the first two letters are used as a symbol. That is capital C and small o. Okay? So in some of the elements, the first letter of their English name is used as a symbol, and in some of the elements, the first two letters of their English name is used as a symbol. And some of the elements, they are not English name, they are Latin names, are used to denote their symbol. Okay, children, like iron. The Latin name of iron is ferrum. And that is why the symbol of iron is taken from its Latin name, not taken from its English name. And the symbol is Fe. Okay. Another example is copper. And the Latin name of copper is cuprum. And the symbol is taken from its Latin name, that is Cu. Capital C and small u is a symbol of copper, which is taken from its Latin. Okay, so these are the three different ways by which the symbols of elements are denoted. Either using the first letter of the English alphabet, English name, that is like carbon, like hydrogen, like oxygen, nitrogen, and all, are the first two letters of their English name, like cobalt, okay, like sodium, and the third way, using the Latin name, the letters of the Latin name, like iron, copper, okay, gold, and all. Understood, children? Now, the next one is the formula. As the symbol is the term used to denote the, yes, elements, whereas the formula is the term used to denote the compound, not the element. So that formula, you can say that is the representation or the way by which we are going to denote the compounds. Okay, and in this formula, the different elements, the symbol of different elements are used which are present in that compound. Now take the example. Iron sulfide. It is a compound. So to write the formula of this compound, Simply we will use the symbols of the different elements which are present in this compound. So these two elements are present here, iron and sulfur. The for symbol of iron is Fe and the symbol of sulfur is S. So we can say that the formula of iron sulfide is FeS. Okay, children? But one more thing is there. The formula of any compound also written or it can shows that the different atoms of these elements which are present in one molecule of that compound. So here in this example of iron sulfide, we can see that the one molecule of this compound, one atom of iron and one atom of sulfur is present here. Okay, now take another example. Carbon dioxide. This is also a compound which is made up from two different elements, carbon and oxygen. The one atom of carbon and the two atoms of oxygen is present here to make one molecule of carbon dioxide. So CO2 indicate for the one molecule of carbon dioxide. So that is why this will termed as the formula of carbon dioxide. So while writing the formula of carbon dioxide, we will write CO2. We will not write only CO or we cannot write as C2O2. The reason is simple that the one molecule is made up from one atom of carbon and two atoms of oxygen, which is fixed. So the ratio of these two elements are 1 is to 2 in carbon dioxide. So always they will present in the same ratio. Okay, children? If one molecule, it will written as CO2. Two molecules of carbon dioxide written as 2CO2. Three molecules will written as 3CO2 and so on. Okay? So, this will termed as simply the formula of compound. So, I hope that you understood about symbol and formula. Is it children? If still you have any doubts, so you can ask your doubt, you can ask your queries in school too. Okay. Now, after that, we have the next topic that is the atomicity. Atomicity. Children, remember that the atomicity is the term made up from atoms. It indicates that the number of atoms which are present in the molecule of that element or the one molecule of any element is made up from how much number of atoms, and that is termed as their atomicity. If that one molecule is made up from two atoms, so its atomicity will consider as 2. If the one molecule of any element is made up from three atoms, so its atomicity will consider as 3. Okay, and if the one molecule is made up from only one atom, so its atomicity will consider as 1. Okay, like helium. It is found in free state in the nature. It means that the one molecule is made up from one atom. So the atomicity of this one is 1. Okay, children? Neon. It is also existing in free state. It means that the one molecule consists of one atom. So we can say that it is also have atomicity 1. But there are other elements who does not exist independently. They join together. Okay, and that is why their atomicity gets changed. Like the oxygen. The one molecule of oxygen is made up from two atoms of oxygen, and that is why its atomicity 2. Okay, so oxygen, nitrogen, atomicity is also 2 because the one molecule of nitrogen is made up from two atoms of nitrogen. Okay, so oxygen, nitrogen, hydrogen, chlorine, these are the elements whose one molecule is made up from two atoms. Okay, and there is a particular term used for it. Those elements are those compounds whose one molecule is made up from one atom or whose atomicity is 1 is termed as monoatomic elements. Mono term indicate for single. Okay, it means that if the number of atoms are present single in one molecule, so such elements will termed as monoatomic elements. And those elements whose one molecule is made up from two atoms, it will termed as diatomic elements. Okay, children? So please remember that the monoatomic in which the number of atoms are 1, diatomic in which the number of atoms are 2. Okay. Now come to the next topic. And the next topic is a very important topic, that is valence. Valency is an important topic of the chapter. Children, please remember that the valency of any element is simply its combining capacity. Means that the one atom of an element combined with how many other atoms of other elements at a time, that will termed as its valency. Like as an individual, I have two hands, so I can combine with two, or I can hold the two things at a time, so that will term as my capacity. So just like that, element combined with how many number of other different elements is termed as their balancing. So we can say that the combining capacity of elements are simply is their balancing. For example, the combining capacity of hydrogen is 1. It means that the valency of hydrogen is 1. It can combine with one other element at a time. So that is why when we are going to write the formula of water, so this indicates that the one atom of oxygen is going to combine with two atoms of hydrogen, because the combining capacity of this oxygen is 2. That is, the valency of oxygen is 2. So it can combine with two hydrogen at a time and forms the one molecule of water, that is represented as H2O. H2O, which is the formula of water, and simply shows that the two atoms of hydrogen are present here and one atom of oxygen is present here. It means that this oxygen atom have the capacity to combine with two hydrogen atoms at a time. Okay, children? Now take some more examples. This valency of hydrochloric acid, HCl. Here also the hydrogen have the valency 1 and chlorine have the valency 1. And that is why to form one molecule of hydrochloric acid, the one atom of hydrogen and one atom of chlorine is present there. And formula is simply written as HCl. In carbon dioxide, whose formula is CO2. Okay, here it's given that the one atom of carbon is going to combine with two atoms of oxygen. It means the combining capacity of carbon is 2. And that is why it can combine with two oxygen atoms at a time. And the formula is CO2. Okay, children? Ammonia. The one molecule of ammonia have the formula NH3. Means that the one molecule of nitrogen is present here and three molecules of hydrogen is present here. So it indicates that the capacity of nitrogen is to combine with three elements of hydrogen. So we can say that the valency of nitrogen will be 3. Okay, so here the valency of nitrogen is 1, chlorine is also 1. Here the valency of oxygen is 2. Here the valency of nitrogen is 3. Okay, and sulfuric acid H2SO4. The formula of sulfuric acid is H2SO4. This indicates that the group sulfate, the one molecule of sulfate group is going to join with two atoms of hydrogen. Okay, children, you can say that the valency of SO4, that is sulfate group, is how much? It is 2. That is why the two hydrogen atoms are joined with it. Sulfate group have the valency 2. Okay, so these are some of the examples that indicates the valency of different elements. Understood, children? Now come to the next, and the next one is the formula. Children, you have to study the formula in detail. As already I have told that the formula indicates the a compound which is made up from two or more than two different elements, and the different elements are present there in what, in numbers. So these all representation is shown by the formula. So as the formula of sulfuric acid is H2SO4. It means that the one molecule of sulfuric acid consists of two atoms of hydrogen and one molecule of sulfate group. Okay. It also indicates that in a molecule of sulfuric acid, hydrogen and sulfate is present, and they are present in the ratio of 2 is to 1. So these all informations we can get from the formula of any compound. Okay, take another example, that is hydrochloric acid. Its formula is HCl. So simply it also indicates that the one molecule of hydrochloric acid is made up from two different elements, hydrogen and chlorine, and they are present in the ratio 1 is to 1. Okay, and we can also say that the one molecule of hydrochloric acid is made up from the one atom of hydrogen and one atom of chlorine. Okay, children. Now come to the next topic of the chapter, that is chemical equation. Chemical equation. When a reaction, chemical reaction is going to occur between the elements and the products are going to form. So this whole representation is termed as chemical equation. It means that when the different reactants react together and after that it forms the product. So this chemical reaction is termed as simply the chemical equation. Okay, and now take an example. When the water molecules, two molecules of water get break together, it forms hydrogen and oxygen. So this will be termed as a chemical equation. Okay, children? Like two atoms of magnesium when react with one molecule of oxygen, it forms two molecules of magnesium oxide. So this representation is termed as chemical equation. And when we are going to discuss about chemical equation, one more thing we have to know about this chemical equation must be balanced. Then the equation will consider as correct. Otherwise, it will consider as incorrect. Take the example. As in the scene, as I have written, the water is going to break into hydrogen and oxygen. If I remove this number and simply, as I told, water, whose formula is H2, is going to break into hydrogen, that is H2, and oxygen. So this statement is correct. But is this for equation will also consider correct? No, this equation will not consider as correct because the number of atoms of different elements are not equal in left hand side and right hand side. That is why between them an arrow sign is used. Okay, so in the left hand side of the arrow and the right hand side of this arrow, the number of atoms of different elements should be equal. Then it that chemical equation will consider as balanced, otherwise it will consider as incorrect equation. So this time this equation will consider as incorrect because in left hand side the number of atom of oxygen is 1 and in right hand side the number of oxygen atoms are 2. It's not equal. So this is an incorrect chemical equation. But as I'm going to write here, the two molecules of water is going to break and form two molecules of hydrogen and one molecule of oxygen. Now this time it will consider as correct because the number of atoms of different elements are equal in left side and right side. Okay, just find it out. Hydrogen atoms in left hand side 2 to the 4 and in right hand side 4. Oxygen atoms in left hand side 2 and in right hand side it's, so we can say that now the all elements are equal in both the sides. So this time this equation will consider as balanced chemical equation. And while writing the chemical equation, we must have to balance it. Then it will consider as correct. Otherwise, it will consider as incorrect. Okay. Now I'm going to take some more example to show you that balancing chemical equation. As nitrogen and hydrogen, they both are going to react together and form the molecule of ammonia. So according to the statement, it's correct. But as we are going to count the number of atoms of the elements, it will consider as incorrect because the number of atoms of nitrogen in left side is 2 and the number of nitrogen atoms in right side is 1. Number of hydrogen atoms in left side 2 and number of hydrogen atoms in right side 3. So we can say that this equation is not balanced as it is incorrect. So we need to balance it. And how we can balance it? Simply by by yes, by equalizing the numbers of atoms in both the sides. So come to the first. Number of nitrogen atoms are 2 here and it's 1 here. So how we can increase it? We can write this simply 2. Now the number of nitrogen atoms get balanced. Both the sides get equal. Now it's time to balance the hydrogen. In left hand side only 2 atoms and right hand side 2 2, 3 are 6 atoms of hydrogen is there. So to balance hydrogen, if I will write here 3, the 3 molecules of hydrogen which contains 6 atoms of hydrogen. Now to get balanced, because in left hand side the number of atoms of hydrogen is 6 and right hand side it's also. So this time this equation will consider as a balanced chemical equation. Understood, children? I hope that you have revised all the topics. Now, thank you and have a nice day.